in this slide, we are going to look at the how controller on-off controller works and how the output oscillates in response to the input. So before we look at this graph, we are going to review this control input and output states. So as mentioned previously, when the error is less than 0, so the output controller will be in off state or 0%. If the controller output is, the error is greater than 0, then the output will be 100% or on state. So we can look at first the set point for this controller. Let's say this dashed line, horizontal dashed line, represent the set point, and this graph represent the process variable. So we can see that process variable increase and touches this set point and then oscillate above the set point, lower the set point for several cycles. So let's investigate further to the input of the process, which is controller output. So when the process variable is less than a set value, or we can say that the error is given by this equation, which is SV set value minus the process variable. So when the PV is less than SV, for example here, the process variable is less than the set value, so the error is positive. So when the error is positive, the controller output here will be 100% or on state. So we write here the controller output is on. So if we look at this controller output here, it is in on state. So that is how the PV rises, and as the PV reaches the set value, the PV becomes more than the set value due to some internal momentum. So during this stage, the equation is already opposite, where we can see that PV already greater than the SV. So meaning that when the PV is greater than SV, the error is negative, and therefore the controller output is set to off. So we can see the controller output is off. So when the controller output is off, what will happen? The PV will return to the original state, or it will be reduced until it reach the set value, and then go further down below the set value, and the cycle repeats. So we can see this behavior of the on-off control, which is on-off state, will be fluctuating, and the same goes to the response, or the process variable will be fluctuating throughout the process. So therefore, this state of control has some advantage, such as simplicity, and also the disadvantage is excessive wear and tear in the final control element. As you can see, the on and off is quite frequent. So that is the scenario when we are dealing with the ideal mode on-off control.